All right, moving on to our next lesson, lesson 3, graphing proportional relationships. Let's look at some vocab. When two quantities, x and y, are proportional, the relationship can be represented by the direct variation equation. Guys, we're flashing back to earlier in the year. We did direct variation already. We also did that equation. So when we discussed direct variation previously, we used the equation y equals kx. Maybe that is ringing a bell. Maybe you're like, don't really remember that. So direct variation equation y equals kx. Now that we are into slope a little bit deeper, and now that we're saying, hey, slope is m, and we keep using that so far this chapter, we're going to replace the constant of proportionality, that k. So if we remember constant of proportionality, we would always use it finding y over x. That is the same thing, k, or constant of proportionality. You were finding slope that entire time. So we were really finding m. Doesn't matter which variable we really use or which terms, because they're all the same thing. We're essentially finding the same thing when we do all of that. So we're going to now use, though we are going to change our direct variation equation, we're now going to use y equals mx, because m is our slope. That's what we're working with this chapter, and that's what we're familiar with more so now. So the graph of y equals mx is a line with a slope of m that passes through the origin. So remember, when graphs were proportional, they had to be two things. They had to be a straight line, and they had to pass through the origin. So that's something important that's still going to carry through here. So when we're graphing proportional relationships, we're still looking for those two key facts. Straight line through the origin. Remember, the origin is the point 0, 0. So let's look at example 1, graphing a proportional relationship. The cost y in dollars for x gigabytes of data on an internet plan is represented by y equals 10x. We want to graph the equation, and then we're going to interpret the slope. So just like in our direct variation equation, I always told you, hey guys, what's the only letter we replace with a number? Before, we would always say k. That was always the only letter we would replace with a number. That's the same fact in y equals mx. The only letter, though, now, again, we changed k to m. So m will be the only one that's going to be a number. So if I look at this given equation, y equals 10x, y equals 10x, m equals 10 here. Remember, m is our slope, so our slope is 10. But they want us to graph this. Remember, to graph an equation, we can do it a few ways, but the way we did it earlier in this chapter so far is I had you create a table, remember? So we're going to create a table. Choose your x values. Now, if you notice here, I only give you the graph for the first quadrant, all positive values, because we're talking about number of gigabytes and money. That can't be negative, so x can't be negative, so we're not going to choose a negative value. We're going to start with maybe 0, and we can just do 1, 2, you can go up to 3 if you want. We're just going to do a few here. So to find y, remember we plug in our x, so 10 times 0 is 0. 1 times 10 is 10, 2 times 10 is 20. And now we're just going to graph this. Our x values are just 1. Our y values, though, we're going up by 10 increments. You can count by 10. You can skip, count by 5s if you want. So I'm going to skip, I'm just going to label like 10, 20, 30, 40. Now we have the point 0, 0, so I'm on that origin there. So I'm going to plot my point. I have the point 1, 10, go over 1 up to 10, go over to 2 up to 20. Maybe you can guess what the rest would be. 3 would be 30, 4 would be 40. You can plot the rest of those points if you want. Again, we just need those 3 points to start our line, connect and continue it through. So good, we graphed it. Now we're going to interpret that slope. What does that slope mean for this problem? So if m equals 10, which is our slope, that means that it's $10 per, what is x representing? gigabytes. Remember, y is giving us money. So to find how much money it is, to find this, we just did 10 times the number of gigabytes. So what this slope means is that it's $10 per gigabyte. That's interpreting. Remember, interpret means to explain. So explain the slope. What does it mean for this problem? That's what we just did. Next, example 2. The weight y of an object on Titan, one of Saturn's moons, is proportional to the weight x of the object on Earth. An object that weighs 105 pounds on Earth would weigh 15 pounds on Titan. We want to write an equation that represents the situation. When we write an equation, it's going to be in y equals mx form. Let's look at what we are given. So the weight y, so y represents the weight of an object on Titan. They tell us that it would be 15 pounds on Titan, so that's our y value. They then say an object that weighs 105 pounds on Earth, so the weight x of objects on Earth. So this would be our x value. So we're given our x and our y. Let's plug that in to find our m, or our slope. Remember, when we're writing an equation in y equals mx form, the only one we want to be a number when we write the final equation is our slope. But we don't have it, so we have to find it. There's a few ways you could find the slope. You could plug in your x and y values to this original equation. So I know my y is 15, my x is 105. So now just solve for m. 15 over 105, you could divide and get a decimal, or you could just simplify this. I would simplify it, I get 1/7. Now another way to find m, and we're not done, but that was one way, m always equals, and if we remember what k always equaled, same thing, it's always y over x. So we could just plug in our 15 over 105, simplify that to 1/7. But careful, our equation is not just 1/7. That's our m. Now we have to plug that in. So our final answer is y equals 1/7 x. That's our entire final answer. We need that whole thing. We want an equation. We don't want to just find what m is. Now let's use that equation to answer part B. It says, how much would a chunk of ice that weighs 3.5 pounds on Titan weigh on Earth? So they're giving us how much it weighs on Titan, so that's our y value. We want to find how much it would weigh on Earth. So let's plug in what we know. Use your equation. So y equals 3.5 now. We still have 1/7 x. We're trying to find x. We could divide by 1/7, or dividing by a fraction is the same as multiplying by its reciprocal. Remember this? So multiply 3.5 by 7. This object would weigh 24.5 pounds on Earth. That's our final answer. And last example here, comparing proportional relationships. The distance y in meters that a 4-person ski lift travels in x seconds is represented by the equation y equals 2.5x. The graph shows the distance that a 2-person ski lift travels. So this is a 2-person, this is a 4-person, the equation. So we're given a graph and an equation. We want to know which ski lift is faster. So guys, if we want to know the speed, okay, look at our x as time to distance. Speed is always our distance over our time, which is our slope. So to figure out which is faster, we need to compare these two slopes. So let's take a look at this 2-person lift, the graph. Let's find, so I'm looking at 2-person, which is the graph. Let's find the slope of that line. Remember, rise over run. So I'm going up, and guys, notice what your y values are counting by. We're counting by 2s actually. So as I go up, I can't just count 1, 2, right? I have to count 2, 4, 6, 8. So it goes up 8, and then it runs, we're counting by ones again, so I can count 1 now. It goes over 1, 2, 3, 4, which means our slope is 2. It's traveling 2 meters per second. Now let's compare that to the slope of the 4-person lift. Guys, look at that graph. It's in y equals mx form. That m, that 2.5, is our slope, which means that the 4-person lift travels at 2.5 meters per second. So which ski lift is faster? The 4-person. It says compare and interpret the steepness of the graphs. So I'm not going to have us graph this equation or anything, but I just want to look at this. If we were to graph it, since the slope is larger or faster, do you think that the 4-person graph would be steeper than the 2-person graph? Hopefully you're thinking yes. Remember, slope represents the steepness of a line. The larger the slope, the steeper it is. So the 4-person lift would be steeper because 2 is less than 2.5. This is steeper. That's the steepness or the slope. So our 2 versus our 4-person lift, the 4-person lift would be steeper. Would be steeper, just so you know. All right, guys, that's it. That's the rest of our lesson.